All right, so let's talk about example 2. Now, example 2 is going to be really, really important. So you may need to watch this particular video once or twice to make sure. There's going to be a lot of information here, so please pay attention. Okay, before we get started, let's talk about this helpful hint. It says, if a transversal is perpendicular to two parallel lines, all 8 angles are congruent. Okay, that's a lot of information. So if a transversal is perpendicular to two parallel lines. So first, let's look at this. Do we have two parallel lines? Yes, we do. We know by these marks right here. So these two lines are parallel. Do we have a transversal cutting those two parallel lines? The answer is yes, we do. This line right here intersects this parallel line and this parallel line. Okay, so that's our transversal. And so it says if a transversal is perpendicular to two parallel lines. So let's say that this, it's perpendicular, right? So what do we know if this is perpendicular? Well, if we have two parallel lines, we know all the corresponding angles are congruent, right? So that means that angle 1, if this is perpendicular, which means it's 90 degrees, the corresponding angle would be right here, which would be 3, right? So that would also be 90 degrees. What else do we know? We know that these two angles are a linear pair, right? So if this is 90 degrees, both of these equal 180. So that means that this has to be 90 degrees on this side, which would mean its corresponding angle, which would be 4, would also be 90 degrees. Okay, cool. What else do we know? Well, we know vertical angles, right? So vertical angles are congruent. So if angle 1 is 90 degrees, that also means that angle 6 is also 90 degrees and perpendicular. Therefore, its corresponding angle, which would be 8, would also be congruent, which would be 90 degrees. And then what else do we know? We know vertical angles again, right? So angle 2 and 5 are congruent. And so this is 90 degrees, and its corresponding angle, which would be 7, would also be 90 degrees. So if you look at it, all of these angles are 90 degrees, and they're all congruent to each other. So you can kind of see how that works. There's a lot of corresponding angles postulate. There's a lot of vertical angles. We can also do a linear pair because we know linear pair, they add up to 180 degrees. So let's read this again. If a transversal is perpendicular to two of the parallel lines, all 8 angles are congruent. So that's kind of interesting. So angle 1 is congruent to angle 2, which is congruent to angle 3, is congruent to angle 4, 5, 6, and 7, 8. They're all congruent. All right. Just a little helpful hint. All right, let's move on to example 2. It says finding angle measures. So first we're given that we're given that line AC is parallel to line DG. So AC is parallel to DG. Okay, we need to prove that angle FBC, this angle right here, FBC, is congruent to GDE. So we need to prove that those two are congruent. All right, let's see if we can do it. That's what we're trying to do. So the given information is that AC is congruent to DG. So no, they're not congruent. They're parallel. I'm sorry. So first off, we know that these two lines are parallel, right? So we know that these lines are parallel. Now, why is it important to know if they're parallel? Well, if you remember, if they're parallel and there's a transversal, then we know we can use the corresponding angles postulate. We know that all the corresponding angles are congruent. So that's super important. Okay, so we're going to write down this given information. We know that line AC is parallel to line DG, and that's just given. Okay, and because that, we know we can use the corresponding angles postulate. So we know we want to try to prove these. So let's go ahead and figure out what is the corresponding angle to this one right here. So we have to determine the transversal, right? So It's the line that cuts through two parallel lines right here. Okay, so this is our transversal. All right. And so what do I know? If I'm gonna take this angle right here, what do I know? The corresponding angle, right? So this is on the bottom of this line, so it'd be the bottom of this one. These are corresponding angles, right? So what I can say is that the angle ABD is congruent to angle GDE. And that we can say that because of the corresponding angles postulate. All right. Now, what I also see, right, so we know that these two are congruent, corresponding angles postulate, but what do I see here? I see that these two angles are congruent because of the, they're congruent because of the, why are they congruent? Because of the vertical angles theorem, right? So I can say that angle FBC is congruent to angle ABD because of the vertical angles theorem. So now I know that these two are congruent. So first off, where do we start? These two are congruent because of the corresponding angles, and then these two are congruent because of the vertical angles theorem. So if I put numbers on, sometimes it's nice. So let's say I'm just making up a number. So if this was like 60, they're congruent, which means this is 60, and vertical angles, this is 60, right? So we know that these are going to be the same. Now, how do we say that? Do you guys remember what theorem it would be? So at this point, we know that these two angles are the same. So we know that angle FBC is congruent to GDE. Angle FBC is congruent to angle GDE because of the transitive property of congruence. Do you remember that? Like if there's an angle that's congruent to the same angle, then those two angles are actually congruent to each other. That's the transitive property of congruence that you guys learned back in chapter, was it chapter 2, right? Yeah, chapter 2. So that leads us to, if you look at this, right? Let's look at these two angles. What are these two angles? So this is, we have two parallel lines, right? There's a transversal. These two angles are actually, they're on the exterior. They're alternate exterior angles. So that really leads us to this new theorem. We just proved this theorem, the alternate exterior angles theorem, which states, and this is a total flashcard moment. So far you have the flashcard of the corresponding angles postulate, and go ahead and add this one to it. The alternate exterior angles theorem states if you have two parallel lines, so we have two parallel lines here. So here's one parallel line, here's another parallel line, and they are cut by a transversal, then the two pairs of alternate exterior angles are congruent. So the exterior angles for these two parallel lines would be these two angles here and these two angles here. So the alternate exterior angles, so 5 and 7 are congruent, and also 6 and 8 by the alternate exterior angles theorem. But remember, the key is these two lines have to be parallel. These two lines have to be parallel, and the parallel lines have to be cut by a transversal. Then you know angle 5 and 7 are congruent, and angle 6 and 8 are congruent. Whew, okay, that's a lot. Let's move on to the next example. So example 2. So what does example 2 say? Okay, so example 2 says, find each angle measure. All right, cool. So this says find the measure. We're going to use this diagram here of measure of EDG. So EDG. Okay, so we need to determine this angle right here. This is the one we're trying to figure out. Right here, this angle. Okay. All right. Yes, EDG. Okay, so right now if we look at EDG, it's just like a algebraic expression, right? So that doesn't really tell us a whole lot. So let's look at the whole picture. What do we see? Number one, I see that we have two parallel lines. And the two parallel lines right here, right? So we have this parallel line here and this parallel line. So those parallel lines really open the door to the corresponding angles postulate and also the alternate exterior angles theorem. So if I was trying to figure out EDG here, I see that these two are corresponding, so we know that those are congruent. And I also see that these two angles right here, the alternate exterior, right, because this is my transversal. I have a transversal that's cutting those two parallel lines right here. So the alternate exterior angles, they are also congruent. Now, if I'm looking at these two equations, I kind of think this one's going to be easier. So I'm going to go for the alternate exterior. So let's go ahead and set this up. The first thing I have to identify is that these two lines are parallel. So I'm going to say line AC, I'm going to use a different color. So line AC, and they are lines, right? Yeah, line AC is parallel to GD, line GD. Or DG would probably be better, but that's okay. And that's just because it's given. And then what I could state is, I kind of need to state this given information. I know that I'm going to say that these two are equal because of the alternate exterior angles, but I'm going to go ahead and define my terms first so then I can set that equation up and then just substitute it in. So this is given. So the next thing I'm going to say is just this given information. The measure of GDE is x minus 30. So measure of angle GDE is equal to x minus 30. And also the measure of angle, and this is really all given information, so I'm just going to erase the two because it's all given. FBC is equal to 75. All right, all of that's given information, right? Okay, so I have these two parallel lines. Now I'm going to say that they are congruent. These two angles are congruent. So I'm going to say to angle FBC, well, no, I'll start here. I should have said it the same way. This should be, I'm going to switch this because GDE, but this is asking for EDG. It's really the same thing, but you should write it as this. So this is EDG. That's how they're writing it. So I should really write it the same way as they're writing it, just to not confuse anybody. Hopefully I didn't confuse you. So EDG is congruent to FBC, angle FBC. And why is that? Because of the alternate, this is where I start like abbreviating, alternate exterior angles theorem. Okay, now I need to substitute these values, and so I have to change the format, right? So it's going to be the measure of angle EDG equals the measure of FBC, which is just the, definition of congruent angles. All right, and now we just kind of substitute those values in. So I'm kind of just going to go up here. I'm going to go kind of high for my 4. And I'm going to substitute these values in. So EDG is x minus 30 equals FBC, which is 75. And that is substitution. Okay, then we just solve, right? So we're going to add 30 to both sides. Okay, 5, that's addition, property of equality. Then we have x equals 75 plus 30, which is 105, and that would be 6. And that's just simplifying. I'm kind of running out of room here. Okay, but what did the problem ask? It asked for EDG. So what is EDG? EDG is x minus 30. So we're going to write that given information again. So the measure of angle EDG is equal to x minus 30. That is given. And then we substitute this in and we get the measure of angle EDG is equal to 105 minus 30. So there's our answer, the measure of angle. Oh, did I forget the G? EDG equals 105 minus 30, which would be, I don't know, let me see. What is 105 minus 30? That would be 75. So 75 degrees. There we have it. There is our answer. Boom shakalaka. Okay, that's A. Let's go ahead and look at B. So what is B? B is BDG. Okay, where's BDG? BDG. Okay, so we need to figure out what X is. All right, so we need to figure out X is. We know that these two lines are parallel, so that means we can do corresponding angles postulate, or we can do alternate exterior angles. This isn't an alternate exterior angle, so we wouldn't really use that one. So we could do the corresponding angles postulate. The only corresponding angles would be that one. But what I see here is I see that I have a linear pair. So I think I'm really just going to do the linear pair theorem. I think that would be the wisest thing. I mean, we just figured out that EDG, yeah, that's what I'm going to do, linear pair theorem. So let's go ahead and figure that out. So linear pair theorem, linear pair theorem, linear pair theorem. Okay, so what I know is I know that angle BDG, angle BDG, and angle EDG, these are supplementary, right? Supplementary angles. Okay, and that's basically, these are supplementary angles, right? And that is, we know that because of the definition of supplementary angles. Okay, now remember back, a while back I said, hey, there's gonna be two things that are gonna go. It's gonna be the definition of the supplementary angles, and then it's the linear pair. So whenever you have two angles that are supplementary, you know that you have a linear pair. So that's what we know now. We know that because we have two angles that are supplementary, we know that we have a linear pair. So we know that the measure of BDG plus the measure of angle EDG is equal to 180 degrees because of the linear pair theorem. Okay? So then we just need to substitute these values in. So, oh gosh, B, did I forget the D? We'll put a little D there. This is BDG, okay? So BDG is X, so we're gonna go X plus measure of EDG. EDG is X plus, oh, was that, X minus 30. Okay, I had that right. X minus 30 equals 180, and that's just substitution, right? Substitution. Okay, so then I just combine like terms, so that ends up X plus X is 2X minus 30 equals 180. That's simplifying, for simplifying. And then we just need to figure out what X is, right? So we're gonna add 30 to both sides. That's the addition. Addition property of equality. That totally just, you guys were probably saying it. Addition property of equality. I don't know where my brain went. It just went blank. Okay, those cancel. I have 2X equals 180 plus 30 would be 210. Right? Yeah, so that's simplifying. And then we divide, so division property of equality, right? division property of equality. Now I'm going to go move up here, and that leaves me with x equals, what's that, 105, right? So that would be 8, and that's simplifying. And then it's asking me for the measure of BDG. And really, the given information is that BDG is equal to x. So I would say the measure of angle BDG is equal to x. That would be 9. That's given information. Therefore, I substitute 105 in for x because x is equal to 105. And I get the measure of angle BDG is equal to 105. And that is because I did substitution. All right, so there we have it. That is how you do those particular problems. All right, let's move up to this, this next example here. So we have a little bit of a proof. We have given angle AC is parallel to DE. What we need to prove is angle ABD is congruent to angle BDE. Okay, so first off, we have that these two lines are parallel. So we have a parallel symbol here, and we have another parallel symbol there, okay? We have a transversal that is cutting those two parallel lines. So that's really awesome. So whenever we have two parallel lines cut by a transversal, what do we know? We know we can use the corresponding angles postulate. We also know that we can use the alternate exterior angles postulate. So what we need to prove is that angle ABD, this angle right here, is congruent to BDE, this angle right here. All right, great. So I think what I want to do first is just write down this given information, right? So line AC is congruent to DE. Okay, that is given. And since we know that, we can use the corresponding angles postulate. So I'm just going to take this, right, this ABD, and what would be the corresponding angle to ABD? Well, the corresponding angle to ABD would be, so ABD would be right here, right? So the corresponding angle would be right here, FDG. So we know that those are congruent because of the corresponding angles postulate. So I'm going to say angle ABD is congruent to FDG, angle FDG, because of the corresponding angles postulate. All right, cool. So then what do we see, right? Well, I see that these two angles are actually vertical angles, which mean that they are the same. So I can say that angle FDG is congruent to BDE. So angle FDG is congruent to angle BDE because of the vertical angles theorem. And, you know, like I said, I like to put numbers. These are just, I'm just making numbers up, right? So if we said this was 70 and the corresponding angles postulate means that's the same, so this would be 70, which would mean that the vertical angles theorem would mean these are the same, so this would also be 70. So it's very clear that these two angles are congruent, and remember, that's what we're trying to prove. So we can say, well, what's the reason? Well, when we look at this, we see that FDG, we have FDG here, and we also have FDG here. So when we have two angles that are congruent to the same angle, what we can say is that those two angles are congruent to each other because of the transitive property of congruence. So ABD is congruent to angle BDE because of the transitive property of congruence. All right, cool. Well, let's look at these two angles. What are these two angles? So remember the two angles that we were trying to prove was this angle right here and this angle right here. And if you look at them, they are actually both interior angles, right? And they're alternate. These are alternate interior angles. So that leads us to the next theorem, the alternate interior angles theorem. And yes, you guessed it, this is a flashcard. Flashcard alert. So we have 3 flashcards so far. We have the corresponding angles postulate, we have the alternate exterior angles theorem, and now we have the alternate interior angles theorem. And what the alternate interior angles theorem states is that if two parallel lines, there we have it again, that parallel line's super important. If we have two parallel lines, so we have two parallel lines here, are cut by a transversal. So we have this transversal here that's cutting these two, right? It's intersecting with this line and this line. So two parallel lines are cut by a transversal. Then the pairs of alternate interior angles. So remember the interior angles here are the angles that are inside, in between. And the alternate interior angles would be angles 1 and 3. They are congruent. And also 2 and 4 by the alternate interior angles theorem. All right, so 3 theorems, corresponding angles postulate, alternate exterior angles theorem, and now the alternate interior angles theorem. So let's go ahead and look at the next example. Okay, so this says, check it out, example 2. It says find the measure of angle ABD. Okay, ABD is right here. Okay, it is right here. So this is the angle that we're trying to figure out right here, right? And what do we see? Ooh, we see that these two lines are parallel. Awesome. Whenever we see two parallel lines that are cut by, do we have a transversal? Yes, we do. Here's our transversal right here. We have a transversal. So whenever we see two parallel lines that are cut by a transversal, we know that we can use the corresponding angles postulate, we can use the alternate exterior angles exterior theorem, or we can use the alternate interior angles theorem. And if you look here, these two angles, they are actually interior angles, and they're alternate interior angles. So I think the smartest theorem would be to use would be the alternate interior angles theorem. So first what I'm going to do first is I'm going to just define our terms. Okay, I think I started off with the parallel lines last time, but then, it's just going to be, well, let's write down this given information. Well, it's really all given, so it doesn't really matter. Okay, well, let's start with the first. We're just going to write down all the given information. So we can write down the parallel lines, that's fine. So we have line AB is parallel to line DE. Oh, it's a line, not a line segment. And DE, those are lines, okay, DE. Okay, that is given information. Okay, what is the other given? Okay, we have ABD, so that would be the measure of ABD is equal to 2x plus 10. Then what else do we have? We have BDE. The measure of BDE is equal to 3x minus 15. Okay, so that's all the given information. Perfect. Now, what do we know? We know these two parallel lines, right? Cut by a transversal. So we can use that alternate interior angles theorem. So the next thing I'm going to say is that the angle ABD is congruent to angle BDE. BDE. And you may think like, well, why don't I just say the measure of ABD is equal to the measure of BDE? And really the reasons why I use the congruence is because the alternate interior angles theorem, it deals with congruent. So it basically, the alternate interior angles, it didn't say equals, it says congruent. So we kind of have to stick with that, right? So 1 is congruent to 3, 2 is congruent to 4. So when we use it, we have to talk about it being congruent, and then we just can switch the format. So this is the alternate interior angles theorem. All right, and now we need to switch it to the equals, which is no problem. We can just go the measure of ABD is equal to the measure of angle BDE by the definition of congruent angles. All right. And then we can just do substitution. So we're just going to substitute these values in. Okay, substitution would be 2x plus 10 equals 3x minus 15. Substitution. And then we just do the algebra from there. So I'm just going to move this smaller. So I'm going to move this 2x over here. And that would be the subtraction property of equality, right? What's this, 5? So subtraction property of equality. I'm left with 10 equals x minus 15. That's simplifying. And then we're going to add 15 to both sides. Addition property of equality. And what's that? That's 25 equals x, which is 8. That's simplifying. And just to have the x on the left side, I'm going to use that symmetric property of equality. And just switch it, symmetric property of equality. All right, cool. So now we know what x equals, but the problem's asking us to figure out what ABD is. So to figure out what ABD is, I have to write down that given information again. So ABD, the measure of angle ABD is equal to 2x plus 10. Okay, that's given. And then we're just going to substitute 25 in for x, right? So that's substitution. We get 2 times 25 plus 10. That's substitution. And then we can just easily simplify that. And we know that 2 times 25 is 50 plus 10 is 60. So there we have it. We have simplify. And we have the answer right there. All right, perfect. And that's how you write it all down. Okay, let's go ahead and move on to our, I think this is the last problem that we're going to talk about here. So we have a proof. We are given that AB is parallel to FE. So AB is parallel to FE. Okay, awesome. We have to prove, oh, this one's different, that the measure of ABD plus the measure of FDB is equal to 180 degrees. Interesting. Okay, this one's different. All right, so let's go ahead and write down what we know. So we know the corresponding, we know that these lines are parallel, right? These lines are parallel. So because these lines are parallel, we know that we can use the corresponding angles postulate, we can use the alternate exterior angles theorem, and we can use the alternate interior angles theorem, okay? So if we have a transversal, which we do right here, so we have access to all of those postulates and theorems because we know that these two lines are parallel. Now, what are we trying to do? Okay, we are trying to prove that, I'm going to say that these two right here, we're trying to prove that angle ABD, so I'm going to use red, this one plus this angle right here, FDB, this angle, we're trying to prove that those add up to equaling 180 degrees. All right, very interesting. And I'm using two different colors because they're not going to be the same. All right, so let's go ahead and just start with the given information. Okay, given information. Boom, 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 given. Okay. Oh, let me use blue. Okay, so we know that this is given. AB is parallel to FE. Okay, so we know that those are parallel. All right, cool. And that is given information. All right, so I'm just going to use the corresponding angles postulate, right? So I know by the corresponding angles, I'm just going to choose this one. The corresponding angle to this angle would be right here. So that means that they're congruent. So these two angles are the same. So what I can say is I can say that angle ABD is congruent to angle FDG. Okay, and these are congruent by the corresponding angles postulate. All right. Now, what I know is that I'm trying to come up with something that's equal to 180 degrees, right? That means they're supplementary. So do you guys see anything here? Well, when we said that these two angles are the same, what happens is I end up having these two angles right here, which they're supplementary, which means they can be a linear pair. Do you guys see that? So that's what I'm going to say. I'm going to say that angle FDG and angle, this one right here, FDB, trying to be careful to make sure that I use the same order in the symbols, are supplementary. And why do we know they're supplementary? Because of the definition of supplementary angles. Definition of supplementary angles. All right, now remember I always said that the definition of supplementary angles goes with the linear pair theorem. So since we know that these two angles are supplementary, we know that they add up to 180 degrees. Okay, so now we're starting to get that equation right. It's not exactly the same, but it is going to be similar. So let's look at it. Measure of angle FDG plus the measure of angle FDB is equal to 180 degrees because of the linear pair theorem. So let's look at, well, this is what we're trying to prove, right? So what's the same, what's different? I always like to do that. So what's the same? We have 180 here, so that's good. That's okay. What else do we have? We have an equal sign, measure of FDB. That's good. We have that right here. So the only thing that is different are these two things, right? We have FDG here and we have ABD there. But if you look back right here, because of that corresponding angles postulate, we prove that those two things are actually congruent, right? ABD is congruent to FDG. So if we just do a little substitution, then boom shakalaka, we have exactly what we need. So we're going to substitute ABD in for FDG here. Oh, but before I have to change the format. Oh, okay, so let's change the format really quick. Maybe I should just, no, okay, fine. We'll change the format. So I can't quite substitute in. So the measure of angle, I should have changed the format up there, but that's okay. ABD is equal to the measure of angle FDG because of the definition of congruent angles. Now we can substitute it in. All right, so 6. Now we substitute measure of angle ABD plus the measure of angle FDB equals 180 degrees because of substitution. Woohoo! And I think we have it. Substitution. Okay. Yeah, we have it all. It's all the same, so we proved it. Awesome. So if you look at these, what were we trying to prove? We were trying to prove that the measure of ABD plus FDB is equal to 180. And these two angles, if you remember, they're same side interior angles. So same side interior angles are actually supplementary to each other. And that leads us to our fourth flashcard, same side interior angles theorem. Flashcard. This is our fourth flashcard. So remember, we have the corresponding angles postulate, we have the alternate exterior angles theorem, we have the alternate interior angles theorem, and now we have the same side interior angles theorem. But all of these are only possible if you have two parallel lines. So you have to have two parallel lines, and those two parallel lines have to be cut by a wonderful, magnificent transversal. All right. And if you have those two parallel lines being cut by a transversal, then what you can say is if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. So same side interior angles are 1 and 4. So that means the measure of angle 1 plus the measure of angle 4 equals 180. And also the measure of angle 2 plus the measure of angle 3 equals 180. So that is our fourth and final postulate theorem for this section. And you have to memorize these because you're going to use these a lot, as well with the vertical angles theorem and the linear pair theorem. Okay, you're going to use them a ton. So memorize them. You can do it. Memorize them, you can do it. All right, and that is it. Thank you, Pause Dragon. You don't need to pause. Okay, he was just kind of excited, and so he wanted to come in and say hi. Hi. Okay, go away. He's enough. All right, it's too much. All right, and that is it for example 2. I know that was a lot. You may want to rewatch this video. I know it's long, but there's a lot of really super crucial information here. And so, yeah, there you have it. All right, we'll see you back in a little bit for example 3.